Hello and welcome to our lesson on scientific notation. Our SWABAT is to write decimal numbers in scientific notation and vice versa. So we're going to go from two forms. We're going to go from decimal form to scientific notation, and then we're going to go from scientific notation to decimal form. A couple things. For decimal form, write this down. For decimal form, you're going to move the decimal to the right for positive exponents. So move right, draw an arrow, for positive exponents. And then you're going to move left, that's an F, for negative exponents. Okay, so if it's right, it's positive, so the number should get bigger. So let's take a look at this one. Rewrite in decimal form. So I have 3.589 times 10 to the fifth power. Looking at this fifth power, it should get a lot bigger because I'm multiplying by like 100,000. So I'm going to start with 3.589. Many of you have seen this before. Because this is a positive 5, I'm going to move to the right. 1, 2, 3, 4, 5. And then with these little extra spots, you are still going to add zeros. So your answer is 3, 5, 8, 9, 0, 0. Put a comma after every 3 or before every 3. Okay, so for the next one, 911, 9.11 times 10 to the negative 5, you have 9.11. Because it's negative, it should get smaller. 1, 2, 3, 4, 5. And then you're going to add your zeros there. I apologize for my singing voice. Don't mind me. It gets worse though. 911. 1, 2, 3, 4, 1, 2, 3, 4. Just counted my zeros to make sure I was all good. So that, beautiful people, is how we go from decimal form to decimal form from scientific notation. The other thing that we're going to do is to go from decimal form now to scientific notation. Couple things. Let's write these down. Number one, there can only be one digit in front of the decimal point. Super important. So it'd be like 1 point blah 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 or 5 point blah blah blah. It's always positive also. 3 point blah blah blah. Never 10 point something, never 13, not 0.1. No, only one number in front of the decimal point. The other thing is that we're always going to multiply by a power of 10. Always multiply by a power of 10. Like 10 to the fifth, 10 to the negative 6, like what we saw here. These are both A and B. These are both considered scientific notation because there's only one number in front of the decimal point, check, and I'm multiplying by a power of 10. This was 10 to the fifth, 10 to the negative fifth. One number only in front of the decimal point. Okay, so let's see what this would be. So first check right here, I need to have only one number in front of the decimal point. So I need this to be 3.51. I'm saying here that I'm going to multiply by a power of 10. Now here's the question. How many times? So I just kind of like to say, this is where I moved it. I can't just move it out of nowhere. How many times do I have to move it back to get to the original? 1, 2, 3. 3 times. Now your next question is it positive or negative? Well, to get back to the original, we went to the left. So it's going to be negative. If you're thinking about a number line, you have 0, 1, -1. The negative numbers are to the left. So I want to go to the left. Also, things to note, if the number is like mad small, you're going to need a negative exponent. If it's huge, you're going to need a positive exponent. Again, if the number is small, mad small is what I had said actually, then you're going to need a negative exponent for that one. Might be worth writing down. So looking at part B, based upon what I just said, I'm looking at 948,000. Small or big number? That's a big number. So you should have what kind of exponent? Positive or negative? Positive. Yes, I was waiting for you to respond. So I'm moving it here. I want it to be 9.48 because I only want one number in front of the decimal point. Just one. And then I'm multiplying by a power of 10. Power of what 10? Well, let's see. 1, 2, 3, 4, 5. to the 5th. And it's positive because that number gets bigger. Looking at it, I moved to the right. All right, let's keep it pushing. Evaluate the expression without using a calculator. What does that mean? You cannot use a calculator. If you do, I'll be able to tell, and that's going to be kind of whack. And then they would like for us to write the result in decimal form. So for a quiz or for a test, for example, you won't be able to use a calculator for this. Why? Because I want you to be able to do two things. Number one, use what we just learned in scientific notation. Number two, use the product property, the power of a power property, all those properties that we have learned previously in this chapter. This is where I want you to apply them in order to simplify things that look like a mess, like for part A, for example. So I have 8 times 10 to the 8th times the quantity 3 times 10 to the negative 5. Now, I don't want to multiply this out and make it like 800 million, whatever. No one cares. What I will do is kind of like multiplying the like terms. So in my head, here's what I'm grouping. 8 times 3, and I can do this because multiplication is commutative, so I can change the order if I want. So I'm going to group those two together, and then I'm also going to group the 10s together. 10 to the 8th times 10 to the negative 5. That's great because I know that 8 times 3 is 24, not a problem for me there. Times, and then I'm multiplying and they have the same base. So if I'm multiplying and they have the same base, I'm going to add the exponents. So 8 plus negative 5, that's cubed. That's great. I'm going to make this a times like that instead. Write the answer in decimal form. So in decimal form, this is 24. If they don't give me a decimal point, it's always at the end. This is a positive 3, so it should get bigger. I'm going to move to the right, and then I'm going to add 3 zeros. So 24,000. That is my answer in decimal form. Just a note, if they told me to write it in scientific notation, it would be 2.4 times, so I moved it there, 1, 2, 3, 4, 10 to the 4th. I don't know if your homework does it or not, so I thought I'd just a little bonus information for you. Okay, same thing. I grouped the two ones that were similar here. I'm going to do the same thing here. So these two together. Okay, I'll make a real circle. I don't know why I was dashing it. 7.7 divided by 1.1. It's 7. But let's show it to make sure that we're all okay. 7.7 divided by 1.1. Move the decimal point over once. Move it over once. 11 goes into 77 7 times. So that part is 7. Times, now you are now dividing and they have the same base, so we should subtract the exponents. Well, what am I subtracting? Subtract negative 9. Negative 9 minus negative 9, kind of hard to say, so I'm going to add the opposite, and I have 10 to the 0. Negative 9 plus 9 is 0. That means I'm not moving the decimal point over at all, so it should just be 7. Does that make sense? Well, it should, because 10 to the 0 power, that's like saying 7 times 1. Anything to the 0 power is 1. So that gives me 7 as well. Scientific notation of this would be 7.0 times 10 to the 0. But this is it in decimal form. All right, last one. So properties we've used so far. We used a to the m times a to the n equals a to the m plus n for letter A. For B, we used a to the m over a to the n equals a to the m minus n. Beautiful. One more property we're going to flash back to, and that is a power of a power. Just kidding, a power of a product. And that says AB to the m equals a to the m b to the n. Well, what does that mean? That means that I am going to distribute that exponent to each term that's in the parentheses. So here and here. They don't give you an exponent here, so I'm going to go ahead and put a 1. So what I'm looking at is 3.4. 1 times 2 is 2, so that's 3.4 squared, times 10, negative 3 times 2 to the negative 6. Now I'm going to multiply 3.4 times 3.4, and I'm going to get, so here's me, 3.4 times 3.4. You're going to trust my math here. And I'm going to tell you that it is 11.56 times 10 to the negative 6. Okay, this is not in decimal form, but I would absolutely like it to be. So this is negative 6. I'm going to move to the left. 1, 2, 3, 4, 5, 6. So how many zeros? 1, 2, 3, 4. This is 0.12341156. That is your answer. And then, just because we've done it a couple times, I'm going to go ahead and tell you, just to review. In scientific notation, this would be 1.156 times 10 to the, move it over, 1, 2, 3, 4, 5. Positive or negative? The negative. It's to the negative power. Okay. Side note there for you. All right. Thank you very much, and have a great day.